Chapter 3 Mole and Chemical Calculations. What is mole? Molar mass, molar volume. How to convert between molar mass, molar volume, and the molar amount of a substance. What is the relative density of a gas A with respect to a gas B? How to use a chemical equation and a chemical formula in chemical calculations. Lesson 18 A mole. As known, the size and mass of an atom and a molecule are very tiny, cannot be weighed, measured, and counted. However, in chemistry, it is necessary to know how many atoms or molecules take part or are formed and what mass and volume of them involved in a chemical reaction. In order to satisfy these requirements, scientists have proposed a concept used for microparticles, very small particles, which is mole, read as mole and noted as MOL. 1. What is a mole? 1 mole is the molar unit amount of a substance containing 6 times 10 to the power of 23 atoms or molecules of that substance. 6 times 10 to the power of 23 is called Avogadro's number and denoted as N uppercase. For example, 1 mole of iron is an amount of iron containing N Fe atoms. 1 mole of water is an amount of water containing N H2O molecules. 2. What is molar mass? Molar mass, denoted as M uppercase, of a substance is an amount measured in grams of N atoms or molecules of that substance. Atomic molar mass or a molecular molar mass of a substance is the same in numerical value with atomic mass or molecular mass of the substance. For example, atomic molar mass of hydrogen mH equals 1 gram per mole. Atomic molar mass of oxygen MO equals 16 grams per mole. Molecular molar mass of hydrogen MH2 equals 2 grams per mole. Molecular molar mass of oxygen MO2 equals 32 grams per mole. Molecular molar mass of water MH2O equals 18 grams per mole. 3. What is the molar volume of a gas? The molar volume of a gas is a volume occupied by N molecules of the gas. It has been determined that 1 mole of any gas at the same temperature and pressure occupies the same volume. At 0 degrees Celsius and 1 atmosphere, known as standard temperature and pressure, denoted as SDP, that volume is 22.4 liters. So, different gases have different values of molar mass at the same temperature and pressure, but their molar volumes are the same. Figure 3.1. At SDP, we have V1 equals V2 equals V3 equals 22.4 liters. At ordinary condition 20 degrees Celsius and 1 atmosphere, 1 mole of a gas occupies a volume of 24 liters. 1. A mole is the molar unit amount of a substance containing N 6 times 10 to the power of 23 atoms or molecules of the substance. 2. The molar mass of a substance is the mass of N atoms or molecules of the substance. measured in gram, the same in numerical value with atomic mass or molecular mass. 3. The molar volume of a gas is the volume occupied by n molecules of the gas. At SDP, molar volume of any gas is 22.4 liters. Do you know? Can you imagine how large the Avogadro's number n equals 6 times 10 to the power of 23 is? Solve the following problem. If we have n grains of rice, how long can this amount of rice feed all humanity? Given that each person has 3 meals per day and eats 5,000 grams of rice per meal. Each person in one day eats 5,000 times 3 is 15,000 grams of rice. At the moment, the population of the world is about 6 billion, 6 times 10 to the power of 9 people who in one day eat 6 times 10 to the power of 9 multiplied by 1.5 times 10 to the power of 4 equals 9 times 10 to the power of 13 grams of rice. In 1 year, they eat 9 times 10 to the power of 13 multiplied by 365 is approximately equal to 3 times 10 to the power of 16 grams of rice. Number of years for people in the world to use up n grams of rice, 1 more grams of rice. 6 times 10 to the power of 23 over 3 times 10 to the power of 16 equals 2 times 10 to the power of 7 equals 20 million years. So it will take millions of years more for people to use up 1 more grams of rice. Exercises 1. Give the number of atoms or molecules in each molar amount of the following substances. A. 1.5 moles of Al atoms. B. 0.5 mole of H2 molecules. C. 0.25 mole of NaCl molecules. D. 0.05 mole of H2O molecules. 2. Find the mass of A. 1 mole of Cl atoms and 1 mole of CO2 molecules. B. 1 mole of Cu atoms and 1 mole of CuO molecules. C. 1 mole of C atoms, 1 mole of CO molecules, 1 mole of CO2 molecules. D. 1 mole of NaCl molecules, 1 mole of C12H22O11 sugar molecules. 3. Find the volume at SDP of A. 1 mole of CO2 molecules, 2 mole of H2 molecules, 1.5 mole of O2 molecules. B. 0.25 mole of O2 molecules and 1.25 mole of N2 molecules. 4. Give the mass of N molecules of following substances: H2O, HCl, Fe2O3, C12H22O11. Lesson 19. Conversion between mass, volume, and molar amount of a substance. In chemical calculation, we usually have to convert the mass and volume of a gas into the molar amount of the gas, and vice versa. We will find out about this conversion. 1. How to convert between the molar amount and mass of a substance. Example, do you know what the mass of a 0.25 mole of CO2 is, given that the molar mass of CO2 is 44 grams per mole? The mass of 0.25 mole of CO2 is mCO2 equals 44 multiplied by 0.25 equals 11 grams. Remarked. Let n lowercase be the number of moles of a substance, m uppercase be the molar mass, and m lowercase be the mass of the substance. We have the following conversion formula. M lowercase equals n multiplied by m uppercase grams implies n equals m lowercase over m uppercase mole. M uppercase equals m lowercase over n grams per mole. From the above converted equations indicate how many moles are there in 32 grams of Cu. The molar mass of compound A given that 0.125 mole of this substance has a weight of 12.25 grams. 2. How to convert between molar amount and volume of a gas. Example. Do you know what the volume in liter of 0.25 mole of CO2 at SDP is? The volume of 0.25 mole of CO2 at SDP is V CO2 equals 22.4 multiplied by 0.25 equals 5.6 liters. Remarked. Let n lowercase be the number of moles of a substance and V uppercase be the volume at SDP. We have the following formulae. V equals 22.4 multiplied by n liters implies n equals V over 22.4 mole. From above converted formulae indicate what is the volume of 0.2 mole of O2 at SDP, what is the number of moles in 1.12 liters of gas A at SDP. 1. Conversion formula between the molar amount n lowercase and the mass m lowercase of a substance. N equals m lowercase over m uppercase mole. M uppercase is the molar mass of the substance. 2. Conversion formula between the molar amount n lowercase and the volume V uppercase of a substance at SDP. N equals V over 22.4 mole. Exercises 1. Which of following conclusions is correct? If two different gases occupy the same volume at the same temperature and pressure. A. They are equal in number of moles. B. They are equal in mass. C. They are equal in number of molecules. D. Nothing can be concluded. 2. Which of following conclusions is correct? The molar volume of a gas depends on A. Temperature of the gas. B. Molar mass of the gas. C. Nature of the gas. D. Pressure of the gas. 3. Calculate A. Number of moles of 28 grams of Fe, 64 grams of Cu, 5.4 grams of Al. B. Volume at SDP of 0.175 mole of CO2, 1.25 moles of H2, 3 moles of N2. C. A molar number of volume at SDP of a mixture including 0.44 gram of CO2, 0.04 gram of H2, and 0.56 gram of N2. 4. Calculate the mass of following amount of substances. A. A half mole of N atoms, 0.1 mole of Cl atoms, 3 moles of O atoms. B. a half mole of N2 molecules, 0.1 mole of CCl2 molecules, 3 moles of O2 molecules. C. 0.10 mole of Fe, 2.15 moles of Cu, 0.80 mole of H2SO4, 0.50 mole of CuSO4. 5. There are 100 grams of oxygen gas and 100 grams of carbon dioxide gas. Both gases are at 20 degrees Celsius and 1 atmosphere. The molar volume at this condition is 24 liters. If they are mixed, no reaction taking place. What is the volume of the mixture? 6. Draw cuboids to compare volumes of the following gases at STP. 1 gram of H2, 8 grams of O2, 3.5 grams of N2, 33 grams of CO2. Lesson 20. The relative density of gases. When we study the properties of a gas, a question arises that how many times is this gas lighter or heavier than a non-gas or than the air? We will study this lesson. 1. How to know whether gas A is lighter or heavier than gas B? To know how many times gas A is lighter or heavier than gas B, we compare the molar mass M uppercase A of gas A with the molar mass MB of gas B. dA to B equals MA over MB. dA to B is the relative density of gas A with respect to gas B. Example, how many times oxygen gas is lighter or heavier than hydrogen gas? DO2 to H2 equals MO2 over MH2 equals 32 over 2 equals 16. Oxygen gas is 16 times heavier than hydrogen gas. 2. How to know whether gas A is lighter or heavier than air? To know how many times gas A is lighter or heavier than air, we compare the molar mass Ma of gas A with the molar mass Mr of the air, which is of 29 grams per mole. dA to air equals Ma over 29. dA to air is the relative density of gas A with respect to the air. A molar mass of the air is the mass of 0.8 mole of nitrogen gas N2 plus the mass of 0.2 mole of oxygen gas O2. Mr equals 28 multiplied by 0.8 plus 32 multiplied by 0.2 is approximately equal to 29 grams per mole. Example, how many times CO2 gas is lighter or heavier than the air? dCO2 to air equals mCO2 over 29 equals 44 over 29 is approximately equal to 1.52. CO2 gas is 1.52 times heavier than the air. The formula for calculating the relative density of gas A with respect to gas B, dA to B equals MA over MB. Gas A with respect to the air, dA to air equals MA over 29. Do you know the decomposition of some inorganic and organic compounds always takes place underground, producing carbon dioxide gas CO2. Carbon dioxide is colorless, odorless, and does not maintain combustion and life of humans and animals. In addition, carbon dioxide is 1.52 times heavier than the air. Therefore, carbon dioxide usually accumulates at the bottom of wells and in cave depths. When humans and animals are down there, they will suffocate if they do not carry oxygen tanks or has not been blown in. Exercises 1. There are following gases: N2, O2, Cl2, CO, SO2. Indicate A. Which gases are lighter or heavier than hydrogen gas, and how many times are they lighter or heavier than hydrogen? B. Which gases are lighter or heavier than air gas, and how many times are they lighter or heavier than air? 2. Find the molar mass of the gases having A. Relative density with respect to oxygen of 1.375, 0.0625. B. Relative density with respect to the air of 2.207, 1.172. 3. Which gases can be collected into a flask or tube? From experiments in the laboratory: hydrogen gas H2, chlorine gas Cl2, carbon dioxide gas CO2, methane gas CH4. By placing it in A. Normal vertical position, B. Upside down vertical position. Explain your answers. Lesson 21. Calculations on chemical formulae. With the chemical formula of a substance, you can determine the mass, a percent of its elements, and vice versa. 1. With the chemical formula of a compound, determine the mass, percent of its elements. Example: a chemical fertilizer has the formula of KNO3. Determine the mass, percent of its elements. Procedure: find molar mass of the compound. MKNO3 equals 39 plus 14 plus 16 multiplied by 3 equals 101 grams per mole. Find the number of atomic moles of each element in 1 mole of the compound. 1 mole of KNO3 consists of 1 mole of K atoms, 1 mole of N atoms, 3 moles of O atoms. The percent by mass of elements in the compound, percent MK equals 39 multiplied by 100% over 101 equals 38.6%. Percent MN equals 14 multiplied by 100% over 101 equals 13.8%. Percent MO equals 100% minus 38.6 and 13.8% equals 47.6%. 2. With the percent composition of its elements, determine the chemical formula of a compound. Example: a compound has the mass, percent of its elements of 40% Cu, 20% S, and 40% O. Determine the chemical formula of the compound, given that the molar mass of the compound is 160 grams per mole. Procedure: find the mass of each element in 1 mole of the compound. MCU equals 160 multiplied by 40 over 100 equals 64 grams. MS equals 160 multiplied by 20 over 100 equals 32 grams. MO equals 160 minus 64 plus 32 equals 64 grams. Find the number of atomic moles of each element in 1 mole of the compound. And Cu equals 64 over 64 equals 1 mole. NS equals 32 over 32 equals 1 mole. NO equals 64 over 16 equals 4 mole. This means in 1 molecule of the compound there are 1 atom of Cu, 1 atom of S, and 4 atoms of O. The chemical formula of the compound is CuSO4. Procedure 1. With the chemical formula, find the mass percent of elements. Find the molar mass of the compound. Find the number of atomic moles of each element in 1 mole of the compound. The rules: find the mass. 2. With the percent composition of elements, find the chemical formula. Find the number of atomic moles of each element in 1 mole of the compound. The rules: construct the chemical formula of the compound. Exercises 1. Find the mass percent of chemical elements in the following compounds: A. CO and CO2, B. Fe3O4 and Fe2O3, C. SO2 and SO3. 2. Find the chemical formulae of compounds which have mass percent of elements as follows. A. Compound A has a molecular molar mass of 58.5 grams per mole. The mass percent of its elements are 60.68% of Cl and the rest is Na. B. Compound B has a molecular molar mass of 106 grams per mole. The mass percent of its elements are 43.4% of Na, 11.3% C, and 45.3% of O. 3. The chemical formula of sugar is C12H22O11. A. How many atomic moles of CHO are there in 1.5 mole of sugar? B. Calculate the molar mass of sugar. C. How many grams of CHO are there in 1 mole of sugar? 4. One type of copper oxide in black color has a molar mass of 80 grams per mole. This oxide has the mass percent of its elements are 80% of Cu, 20% of O. Find the chemical formula of the above copper oxide. 5. Find chemical formula of gas A given that gas A is 17 times heavier than hydrogen gas. The mass percent of gas A are 5.88% of H and 94.12% of S. Lesson 22. Calculations on chemical equations. When any substance is prepared in laboratory or in industry, the amount of reactants, starting materials, can be calculated. On the contrary, with a fixed amount of material, the amount of substance formed products can be calculated. 1. How to calculate the mass of reactants and products. Example 1. Calcining, limestone, quicklime, and carbon dioxide gas are 10. CaCO3 heat to form CaO plus CO2. Calculate the mass of quicklime obtained when 50 grams of CaCO3 is calcined. Procedure. Find the number of moles of CaCO3 taking part in the reaction. And CaCO3 equals lowercase CaCO3 over M uppercase CaCO3 equals 50 over 100 equals 0.5 mole. Find the number of moles of CaCO obtained after calcining. From the chemical equation, with 1 mole of CaCO3 taking part in reaction, 1 mole of CaO is obtained, leading to the conclusion that a half of mole of CaCO3 produces a half of mole of CaO. Find the mass of obtained quicklime CaO. MCaO equals N multiplied by M uppercase CaO equals 0.5 multiplied by 56 equals 28 grams. Example 2. Calculate the mass of CaCO3 needed to repair 42 grams of CaO. Procedure. Write chemical equation for repairing CaO from CaCO3. CaCO3 heat to form CaO plus CO2. Find number of moles of CaO formed after the reaction. NCaO equals M lowercase CaO over M uppercase CaO equals 42 over 56 equals 0.75 mole. Find the number of moles of CaCO3 used in the reaction. From the chemical equation, 1 mole of CaCO3 should be calcined to repair 1 mole of CaO. Thus, 0.75 mole of CaCO3 should be calcined to repair 0.75 mole of CaO. Calculate the mass of CaCO3 needed. MCaCO3 equals N multiplied by M uppercase CaCO3 equals 0.75 multiplied by 100 equals 75 grams. 2. How to find the volume of the gas reactant and the gas product. Example 1. Carbon is burned in oxygen or air, producing carbon dioxide. C plus O2 heat to form CO2. Find the volume of carbon dioxide CO2 produced at SDP if 4 grams of oxygen gas is used in the reaction. Procedure. Find the number of moles of oxygen used in the reaction. NO2 equals 4 over 32 equals 0.125 mole. Find the number of moles of CO2 produced after the reaction. From the chemical equation, 1 mole of O2 used in the reaction produces 1 mole of CO2. Thus, 0.125 mole of O2 in this reaction produces 0.125 mole of CO2. Find the volume of CO2 gas at SDP produced after the reaction. VCO2 equals 22.4 multiplied by N equals 22.4 multiplied by 0.125 equals 2.8 liters. Example 2. Find the volume of oxygen at SDP needed to burn 24 grams of carbon completely. Procedure. Write the chemical equation of the combustion of carbon in oxygen. C plus O2 heat to form CO2. Find the number of moles of C used in the reaction. NC equals 24 over 12 equals 2 moles. Find the number of moles of oxygen used in the reaction. From the chemical reaction, 1 mole of O2 is needed to burn 1 mole of C completely. Thus, 2 moles of O2 is needed to burn 2 moles of C. Find the volume of oxygen needed at SDP. VO2 equals 22.4 multiplied by N equals 22.4 multiplied by 2 equals 44.8 liters. Procedure 1. Write the chemical equation. 2. Convert the mass or the volume of the gas into the number of moles of the substance. 3. Find the number of moles of the reactants and the products based on the chemical equation. 4. Convert the number of moles of the substance into the mass of gas. M lowercase equals N multiplied by M uppercase, or the volume of gas at STP. V equals 22.4 multiplied by N. Exercises 1. Iron reacts with hydrochloric acid. Fe plus 2 HCl arrow FeCl2 plus H2. If 2.8 grams of iron is used in the reaction, find A. The volume of hydrogen gas obtained at STP. B. The mass of hydrochloric acid needed. 2. Sulfur is burned in air to form a gas with pungent and irritating smell, that is sulfur dioxide or sulfur gas, which has chemical formula of SO2. A. Write the chemical equation of the combustion of sulfur in the air. B. Given that the mass of sulfur used in the reaction is 1.6 grams, find the volume of sulfur dioxide produced at STP, the volume of air needed at STP, given that 1/5 of the air by volume is oxygen. 3. A chemical equation is as follows. CaCO3 heat to form CaO plus CO2. A. How many grams of CaCO3 is needed to repair 11.2 grams of CaO? B. How many grams of CaCO3 is needed to repair 7 grams of CaO? C. If 3.5 moles of CaCO3 is used in the reaction, how many liters of CO2 at STP is produced? D. If 13.44 liters of CO2 at STP is obtained, how many grams of the solid have been used and have been produced in the reaction? 4 asterisk. A. Carbon dioxide CO reacts with oxygen gas forming carbon dioxide. Write the chemical reaction. B. How many moles of oxygen is needed to burn 20 moles of CO in order to obtain only one gas after the reaction? C. Fill in the blank cells with the number of moles of reactants and products after different time intervals. Given that the initial mixture of CO and O2 has the same molar ratio as the molar ratio in the chemical reaction. Time at the beginning T0. Number of moles reactant CO 20, O2 blank. Number of moles product CO2 blank. Time at T1. Number of moles reactants CO 15, O2 blank. Number of moles product CO2 blank. Time at T2. Number of moles reactant CO blank. O2 1.5. A number of moles product CO2 blank. Time at the end T3. A number of moles reactant CO blank. O2 blank. Number of moles products CO2 20. 5 asterisk. Find the volume of oxygen needed to burn 11.2 liters of gas A, given that gas A has the relative density with respect to the air of 0.552. The percent composition of elements of gas A are 75% of C and 25% of H. All volumes are measured at SDP. Lesson 23. Review 4. To consolidate the concepts of moles, molar mass, molar volume, and relative density of gases, to consolidate the relation among the mass of substances, the amount of substances, and the volume of gases, as well as apply the knowledge to solve problems and explain the natural phenomena. 1. Key knowledge. 1 mole. What do the following phrases mean? 1 mole of Cu atoms, 1.5 moles of H atoms, 2 moles of H2 molecules, 0.15 mole of H2O molecules. Their meanings. 1 n of Cu atoms, or 6 times 10 to the power of 23 Cu atoms, 1.5 n's of H atoms, or 9 times 10 to the power of 23 H atoms. 2 n's of H2 molecules, or 12 times 10 to the power of 23 H2 molecules. 0.15 n of H2O molecules, or 0.9 times 10 to the power of 23 H2O molecules. 2. Molar mass. What do the following sentences mean? The molar mass of water is 18 grams per mole. The atomic molar mass of hydrogen is 1 gram per mole. The molecular molar mass of hydrogen is 2 grams per mole. The mass of 1.5 moles of water is 27 grams. Their meanings. The mass of n molecules of water, or 6 times 10 to the power of 23 molecules of water, is 18 grams, denoted as M uppercase H2O equals 18 grams per mole. The mass of n atoms of hydrogen H, or 6 times 10 to the power of 23 atoms of H, is 1 gram, denoted as mH equals 1 gram per mole. The mass of n molecules of hydrogen H2, or 6 times 10 to the power of 23 molecules of H2, is 18 grams, denoted as mH2 equals 2 grams per mole. The mass of 1.5 n's molecules of H2O, or 9 times 10 to the power of 23 molecules of H2O, is 27 grams. 3. Molar volume. State. The molar volume of gases at the same temperature and pressure. The molar mass of gases at standard temperature and pressure, 0 degrees Celsius and 1 atmosphere. The molar mass and the molar volume of different gases. Answer. At the same temperature and pressure, 1 mole of any gas occupies the same volume. If the temperature is 0 degrees Celsius and the pressure is 1 atmosphere, that volume is 22.4 liters. Although different gases H2, O2, CO2 have unequal molar masses, MH2 equals 2 grams per mole, MO2 equals 32 grams per mole, MCO2 equals 44 grams per mole. They occupy the same volume at the same temperature and pressure. At SDP, VH2 equals VO2 equals VCO2 equals 22.4 liters. And the following scheme shows the conversion between amount, number of moles, mass, volume of gases at SDP. mass of the compound m lowercase arrow a number of moles n equals m up lowercase over m uppercase. N arrow volume of gas V equals 22.4 multiplied by N. V arrow N equals V over 22.4. N arrow M lowercase equals N multiplied by M uppercase. M uppercase molar mass. 4. The relative density of a gas. What do the following sentences mean? The relative density of gas A with respect to gas B, dA to B is 1.5. The relative density of CO2 gas with respect to the air, dCO2 to air is 1.52. Their meanings. The molar mass of gas A is 1.5 times bigger than the molar mass of gas B, or the molecular mass of gas A is 1.5 times heavier than that of gas B. The molar mass of CO2 gas is 1.52 times bigger than the molar mass of the air, or the mass of 1 V of CO2 is 1.52 times larger than the mass of 1 V of the air. Volumes of gases are measured at the same temperature and pressure. 2. Exercises. 1. Find the simplest chemical formula of a sulfur oxide in which 2 grams of sulfur combines with 3 grams of oxygen. 2. Find the chemical formula of a compound which has the mass percent of its elements as follows: 36.8% of Fe, 21.0% of S, and 42.2% of O. The molar mass of this compound is 152 grams per mole. 3. A compound has the chemical formula of K2CO3. Calculate A. The molar mass of this compound. B. The mass percent of element components of the compound. 4. A chemical equation is as follows: CaCO3 calcium carbonate plus 2HCl hydrochloric acid arrow CaCl2 calcium chloride plus CO2 carbon dioxide plus H2O water. A. Calculate the mass of calcium chloride obtained when 10 grams of calcium carbonate reacts with an excess quantity of hydrochloric acid. B. Calculate the volume of carbon dioxide obtained in the laboratory. If 5 grams of calcium carbonate reacts completely with an acid, given that the volume of 1 mole of a gas at ambient condition is 24 liters. 5. Methane gas CH4 exists in nature or in biogas. Methane gas burns in air, producing carbon dioxide gas and water. CH4 plus 2O2 heat to form CO2 plus 2H2O. A. Calculate the volume of oxygen needed to burn 2 liters of methane completely. The volumes of gases are measured at the same temperature and pressure. B. Calculate the volume of carbon dioxide at STP obtained after the combustion of 0.15 mole of methane. C. How many times is methane gas lighter or heavier than the air?